Welcome! In this series of short videos, we will look at topics common to the PowerBasic Windows compiler. Today we will look at using runtime or explicit dynamic linking of DLLs to allow multi-language support in your applications. We have in previous videos covered the creation of dynamic link libraries, DLLs. With those DLLs, we've used the common load time implicit linking, sometimes referred to as early binding. This works fine when you're accessing your own DLLs. However, should the DLL not be accessible from your application will error when loading. We can demonstrate this quite easily. We have declared a function called funTest in a library called test.dll. This DLL does not exist. PowerBasic will allow you to compile this application without error, because it does not check for the existence of this DLL at compilation time. We can even create a call to that function within our PB main function, and the application will still compile. However, if we attempt to run the application, an error will be created. It will report that the code cannot continue because test.dll was not found. Even if you put code within your application to test for the presence of the DLL, that code will never be executed, because when your application runs, it will first test for any dependencies, and this DLL is one of them. And as it does not exist, the user will always get this system error appearing on screen. This is not particularly user-friendly and gives no guidance to the user as to where they can obtain the DLL or what they need to do to report the problem. So what we're going to look at today is implemented runtime or explicit dynamic linking of the DLL. This approach will allow you to actually test for the presence of the DLL, and if the DLL does not exist, you can take appropriate action. So when would you wish to use this approach to accessing functions or subroutines within a DLL? One possibility is that the DLL you're accessing is not one of your own. It is perhaps a third-party library which you're making use of the functions within it. As it is a third-party library or application, you may not have control over when it gets installed on a particular computer. So it's useful when your application loads to test for the presence of this dependency. And should it not be found, you can then display to the user a reasonable message on screen telling them what they need to do in order to get this installed, or at the very least how to report the problem. A second reason for using this particular approach is if you wish your application to support multiple languages. And that scenario is what we're going to look at today. Let's have a look at some code. So in this Windows application we have, it's a very simple dialog that will appear to the user on the screen. The dialog will show 3 flags for 3 nationalities: French, the Netherlands, and the UK. We want our application to support 3 separate languages, and the first screen provided to the user is for them to select which language to use. So that when the user clicks on, for example, the French flag, then the application will access a particular DLL handling all the French text. Should they pick one of the other buttons, it will then link to that particular DLL. So let's create that DLL first of all. So here we have the source code for a quite straightforward DLL. Creating a DLL is quite straightforward. We click on the icon at the top left-hand corner to create a new file, and we pick DLL framework using libmain. This gives you a skeleton which you can then use to populate your DLL. It creates the main entry point for you. And after that, we have added 2 functions within this DLL, one called return greeting and one called say goodbye. These are very simple functions set up simply to return a string of text, one to say good morning and one to say goodbye. In defining a function within a DLL, you need to say that you wish to export that function should you wish to actually call that function from outside the DLL. If you exclude the word export, then the function is considered private to the DLL and cannot be accessed from outside. We can simply compile this DLL by clicking on the compile button. So we can now see that we've got a libEnglish.dll created in our folder. So we're going to make a call to that first. As the user will be clicking on one of the flags, we need to put something into the callback function, the event handler, to handle that event. These are the events that handle clicking on each of the image buttons. So we're going to do a call to a Windows API function called loadLibrary. This will return a handle, which we're going to have as a global, which we will declare in a moment. And the single parameter loadLibrary takes is the name of the DLL. This instructs Windows to load the DLL into memory. So we will declare that global handle at the top of our code. So while we have loaded the library into memory, we have not done anything to specify the functions within the library yet. That is our next task. We have declared a new function called getPhrase. This is a function we're going to use to return the text we're looking for. If we look back into the event handler, we can now put another piece of code below the endSelect statement. At this point, the user will have selected one of the 3 flags on the dialog, and the library at this point should have been loaded. So we can test this. If the value returned from loadLibrary is 0, then for some reason we have been unable to load the library, and we can then take whatever action we consider relevant. In this case, I'm just displaying a message box to the user on the screen to say we are unable to load the language library. Below the 3 flags on our dialog is a simple label box, and we're going to populate that with the text. We're going to use a standard control set text command to update the value of that label with the text we get back from our library. So we're going to create this funGetText function, and it will take as a parameter the name of the function within our dynamic link library that's going to return the value. So let's create that function now. Here is the new function getText. It takes the single parameter, which in this case is the phrase we're looking for, and we're converting it on the fly from a standard string to an ASCII Z. This is because we're going to be calling one of the Windows API functions, and this one is going to take an ASCII Z value. While we have loaded the library into memory, we do not yet have a way of getting at the functions within that library. And this is what we're going to do next. We're going to call an API function called getProcAddress, which will get us the address of the process we wish to call. So we will declare 2 local variables, hproc, which is the D word, which is the return from this call to the Windows API function, and strtext is going to be the text we actually populate. getProcAddress takes 2 parameters. The first being the global handle for the library itself, which we got a moment ago, and the second being the phrase. This is the function within that library we're actually going to be calling. We can test the return hproc to ensure that the getProcAddress did indeed return a value. If it's something other than 0, then we got a value. If the value is 0, then we'll just return an empty len string. Now we're going to put the single line of code in that's going to allow us to call the function within our library. And this is the one we declared earlier. We have defined this as funGetPhrase. So we're using call dword to call the handle we got a moment ago from getProcAddress. We're using funGetPhrase as our function and we're getting the string that appears out of that function to strtext. So once strtext is actually populated, all we need to do then is return that as the value of the function. So if we try running that code now, our dialog displays, and if we click on the UK flag, we get the response coming back saying good morning. Having loaded a library into memory, it's good practice to unload it when you're no longer using it. So we're going to put some code in to do that now. As our intention is for the user to pick one of the flags at the beginning of the application, the library should remain loaded for the duration of the application itself. And then once the user attempts to leave the application, we can then unload our library before exiting our application. In our callback function, our event handler, we're going to put a bit of code in the wm destroy event. This will allow us to do two things. One, to show a goodbye message to the user, and the second, to free up the library. So in the moment, we will create a new mini dialog to allow us to say goodbye to the user. And as the last act of this form closing down, before the application ends, we will test the value of our handle to the library. If it is not 0, then we will call another Windows API call called freeLibrary. It takes the single parameter, which is the dword of our handle. This will instruct Windows that this application is no longer using this DLL. And if there are no other applications using the DLL, Windows will then unload it from memory. So let's create this new mini dialog. This is going to be a very simple modeless dialog. It will only have one label control on the dialog itself, and this will contain our goodbye message in whatever language the user has actually selected. As this is going to be a modeless dialog, there will be no event handler for it. So we merely have to display the dialog on screen. In this case, we're doing so without any dialog borders, and we're going to populate this single label control with a goodbye message. And we're going to use our getText function we have already created with a single parameter of the name of the function in a DLL that will contain the goodbye message. If for any reason the value returned from this function is a 0-line string, then we will just display in English the word goodbye. So having populated the label control with the word goodbye, we can then show the dialog in a modeless form. When displaying a modeless dialog, the code executes immediately after the command to show that dialog on screen. For such dialogs, you would normally expect a message pump, but as we don't expect the user to do anything with the dialog, we can merely wait 2 seconds and allow the dialog to end, and this will effectively end our application. So if we try running our code now, and we select UK flag, and if we close the dialog down, we will get the pop-up dialog appearing with the word goodbye. So having created an application which will pull text from a DLL, we can now add our additional language libraries. So the format of the DLLs for the two additional languages, both Dutch and French, will follow exactly the same format. They will contain the same two functions, however they will return the text in that particular language. For returning a good morning greeting, and for returning goodbye. The French one is exactly the same. So if we compile both of these to give our DLLs. And having created both of these DLLs, we can then amend the main application to call them. In the event handler, the callback function, we can put the code in to call each individual library. So when the user clicks the French flag, they get the French DLL. And similarly, when they click the flag of the Netherlands, they will get the DLL for that country as well. So if we try running our application now, and click on one of the other flags, it displays the detail on the screen of the greeting, and when we close down, we'll display the goodbye message. when we run it for the Netherlands, we get the same, but in that language. While these are very simple functions to return a single piece of text, they show you the construct you can use to build upon. This way, once your application is actually created and you're calling this library or these libraries to populate the text on your screen, adding an additional language is not going to be particularly difficult. You merely have to create the DLL for that language with exactly the same functions as all the other DLLs. Hopefully you'll find this approach useful in your applications, but that's it for today. Thank you for watching.